Good afternoon to everyone. My name is Archit Priyadarshi and my registration number is 25BAI1475. So, in this PPT, we're gonna learn about red black tree. So, let's get start. So, first of all, we'll see what is red black tree. So, a red black tree is a self balancing binary search tree which is used in data structures to keep the tree balanced so operations stay fast. And the time complexity for operations are given below. So here for search operation it takes O log n, for insert it is same, that is O log n, and for delete it is same. And now we're gonna learn what is the difference between AVL tree and red black tree. Like if we have AVL tree, why do we need a red black tree? What is the difference between AVL tree and red black tree? So in AVL tree, more rotations are needed during insertion and deletion because it is strictly balanced and it uses height difference as a balance factor. But in red black tree, insertion and trees are not strictly balanced, it is loosely balanced and fewer rotations are needed. And it also uses red and black colors to identify the nodes. And insertion and deletions are faster in this. In AVL tree, searching is faster, and in red black tree, insertion and deletion are faster than AVL tree. Now we're gonna learn about the properties of a red black tree. So the first property of a red black tree is every node is either red or black. The second property says the root node is always black. The third property says no two consecutive red nodes should be present. Like a parent and his child cannot be read at the same time. So every path from a node to its null children has the same number of black nodes. Okay, and the last property says the leaf nodes null are considered black. So these all rules ensure that the tree stays approximately balanced. So such example of a balanced red black tree is this. The first property says that every node is either red or black. In this example, every node is either black or either red. The second property says the root node is always black. As you can see, 10 is the root node and it is black. The third one says no two consecutive red nodes should be present. It means a parent and his child should not be read at the same time. As you can see, in this example, a parent and a child is not read at the same time. And the fourth property said every path from a node to its null children has the same number of black nodes. So consider this path 10, 5, 3, 1 and nil. So this path has total 3 black nodes, that is 10, 3 and nil. And now consider this path 10, 15, 12, 13 and nil. So in this path also 10, 12 and nil are the 3 black nodes. Now consider this path 10, 15, 18 and 17 and nil. In this path also 10, 15, 10, 18 and nil are the 3 black nodes. Consider this path 10, 5, 7 and nil. In this path also 10, 7 and nil are the 3 black nodes. So it is also following this property. Now the leaf nodes are considered black. The leaf node that is null, they are considered black, as you can see. Now this is the violation of the rule that a parent and a child cannot be read at the same time. So this is a violation. We cannot do this in red black tree. Now we will learn about the coloring and rotation rules. So whenever red case happens, it means when a parent and his child are both red. So check uncle, it means check the sibling of the parent. Now if uncle is red, so change parent color to black, uncle to black. If there is no uncle node, then it is a null node which is still black. and change grandparent node to red. The special rule, there is a special rule for root that it remains always black. So we must take care of it also. And if uncle is black, then we have to perform rotations. A left rotation, right rotation, left right rotation. We can perform rotations. Now, here is such example. So it says insert elements 10, 18, 7, 15, 16 from left to right. So we have to insert 10 first and then so on to 16. So step 1 is to insert 10. So 10 becomes the root node, so which is always remain in black color. So I've identified B. I've given it a B. Now step 2 says insert 18. Since it is a binary search tree, 18 is greater than 10, so we are putting it to the right, and 18 becomes red. Now, step 3 says insert 7. Since it is a binary search tree, we have to insert 7 at the left. Here both children, and now in this case, see, both children are red, but no red-red parent conflict because the parent is black. So it is still valid. Now we have to see the step 4. In step 4, we have to insert 15. Now we have to insert 15. We have to insert 15, so it's a binary search tree. So 15 will be inserted at the left as a left child of 18. Now we can see a red parent and a red child case. So this basically violates the rule that no two red nodes together. So we have to check the uncle. If uncle is red, we have to change the color of parent, child and grandparent. And if uncle is black, we have to perform rotations. Now the uncle 7, the uncle of 15 is 7 and it is red. So we have to recolor it. Since we have to recolor, it. So it becomes black. The parent becomes black, grandparent become red, and the uncle become black. But root must be black. So we have to change 10 back to black. So 10 will become black again. As you can see, 10 become black again. Now we have to insert 16. Now 16 will be inserted as a right child of 15. Again, there is a red violation, as you can see. Here the uncle is null. So this is child, this is father, and there is no sibling of the father, 15. So we have to perform rotation. First left rotation on 15, then right rotation on 18. And the final balanced tree will look something like this. So this is the AVL final balanced red-black tree. Thank you so much. That's it.